Okay guys, let's do a quick review of linear relationships. So just so you know, it is on your formula chart, but it's called the slope-intercept form. So a linear relationship is a relationship between two quantities where both change by their own constant amount. The y-intercept is the value of y when x is 0. And it's also where the line crosses the y-intercept. The y-axis. Y-axis. So in a table, you would look for the value, let's say it was here, the value of y when x is 0. So the y-intercept would be a positive 5 in this situation, or the coordinate 0, 5. I'm going crazy. Okay, and then the same graph would be represented here. The y-intercept, let's say it's going through at 5, so 0, 5. The y-intercept would be 5. So it's either where on the table x is 0 or where the line goes through the y-axis. The independent quantity is your x, and it is a quantity or variable that affects another. The dependent quantity is a quantity or variable that is changed when another one changes. So it depends on the independent. So independent could be like number of hours, could be units, and then generally like the dependent could be cost, or like total. So the dependent will change at a constant rate as the independent changes. So let's take a look at y equals mx plus b. So y, like we said, is going to be the dependent quantity. So we usually see it as the cost or the total. And then m is our rate of change. So rate of change is change in y minus change in x. So think about the word change. What operation do you think about with change? So if something changes, it's usually different, right? So you're going to find the difference, or you're going to subtract. So if you're looking at a table, it's going to be y2. So you take the second y on the table minus y1 over x2 minus x1. And we will take another look at that in a minute. But remember that it's change, so you're finding the difference. So mx. So if we look at m and x together, what operation are we doing? We're multiplying, right? So you want to look for words that mean multiply. So we are looking for per and each, words like that. X is our independent quantity. So usually that's, like we said, like a number of units. It could be ounces, number of hours. It just kind of depends on the situation. So, but it is the quantity that the dependent variable changes in relationship to. And then the y-intercept, we said, is the value of y when x equals 0. So we're looking for when the line goes through the y-axis, or on a table when x equals 0. So if you look at that, what operation are we doing? We're adding it, right? Or it could be down here. We could be subtracting it. So you're looking for adding, or subtracting. So this is going to usually be like a deposit or a one-time fee, or like a starting point. Okay, so now that we've dug deeper into the equation, let's take a look at some examples. Oh, first, tables. So with a table, I just want you to know you can either see it vertically, like up and down, or horizontally, left to right, and your x is always going to come first. X, and then y. X on top, Y on the bottom. And remember that X is your independent quantity. Oh, my screen stopped working. There we go. My independent quantity. Let's try this again. And Y is your dependent. So think about when you guys are going to get to drive, you always need to take your ID with you. So I comes first, D is second, X, Y. All right, now let's look at an example. So to take a linear relationship from a graph and put it on a table, you're always going to work from the left to the right. And you want to identify points on the line where it goes through the grid. So we are looking here, here, I see here it's going through, here, and here. So you're always going to go from left to right. So I'm going to start here at -8, right? Because coordinates, you do X first. So I go left first and then up. So -8, 6. Then I have -4, 4. I have 0, 2, and I have 4, 0. Okay, so now looking at that, first thing I want to identify is my y-intercept, right? So at this point, the line is going through the y-axis. So this point is 0, 2. So I'm going to circle that here, and I'm going to make sure everybody knows I know this is the y-intercept. Okay, so another thing that I need to write my equation, or my, equation, sorry, is the rate of change. So remember, we know that the rate of change in y over change in x. So to find change, I'm going to take the difference. So 4 minus 6, right? I'm going to do 4 minus 6 equals -2, right? Add a negative, different sign, so I'm going to subtract, take the sign of the bigger one. 2 minus 4 is -2, and 0 minus 2 is -2. And then I need to do change in x. So -4 minus -8. So minus a negative means add a positive. 8 minus 4 is 4. Keep the sign of the bigger one, so it's +4. 0 minus -4, +4. 4 minus 0, +4. So change in y over change in x, -2 over 4, and I can simplify that by dividing them both by 2. So I keep my negative, 1 over 2, right? That becomes a 1. That becomes a 2. So my rate of change is -1/2. Now another way I could have known that it's negative is because you want to look at your line. If it's going downhill, if you're walking on the line from left to right, it's going downhill, that's a -m. And if it's going uphill from left to right, it's a +m. So let's look at y equals mx plus b. So I'm going to fill in what I know. So y equals, m is my rate of change, -1/2 x, and then plus b. It's a +2. Okay? You guys got this. Let's try it again just for assurance. Okay, so which equation best represents the relationship between the independent and dependent quantities in the table below? So I'm always going to try to find my y-intercept first. Do I have an x value of 0? No. Don't get confused because you see y is 0. And if you need to plot them on a graph, then do that. You can take the time to draw a graph if that helps you understand. So if I did, let's see, x is 3, 1, 2, 3, 0. 4, 5, 6, 7, 8. So I have 1, 2, 3, 4. So then the second is 6, 1. So 1, 2, 3, 4, 5, 6, 1. So I can see that we're going to be uphill. So my m is going to be what? Positive. Good. So I don't have a x value of 0, so I need to add it in. So how can I do that? I need to get an x value of 0. Let's work with our rate of change to find it. So change in y over change in x. So 3 minus 2, 1. 2 minus 1, 1. 1 minus 0, 1. Now let's go up top. 12 minus 9, 3. Oops. 9 minus 6, 3. 6 minus 3, 3. So my change in y is 1. My change in x is 3. So to get from 3 to 0, I have to change by 3. I subtract 3, right? So if I'm changing at a rate of 3 up top, what is my rate on the bottom? 1. So 0 minus 1 is negative 1. So I would go through the y-axis right here. So 0, negative 1. Knowing that, let's write our equation. So y equals 1/3 x, and then plus b, but it's negative, so minus 1. Do I have the right situation? Yep, here we go. And initially, you can look at the y-intercept, right? So we knew that this one had to verify it was the right answer because it was negative 1. Okay, so let's look one last time at a word problem and us creating the table and the relationship. So the car dealership starts off with 255 cars each week. They sell 30 cars per day. I'm thinking multiplying. This sounds like a starting point to me. Point. Use a table. Oh no, hang on, keep. Oh, what'd I do? Okay, sorry, I've had technical difficulties. Okay, so use the table to represent the relationship. So first of all, can we go ahead and say the equation? We know y equals mx plus b. So if it's 30 cars per day, that means I'm multiplying. So that's my what? My m, good. So y equals 30x, and then the starting point. Now they're selling cars. Is that going to be positive or negative? I would say negative, right? They're selling 30 cars per week, and they started off with 255 cars. So that sounds like my intercept, so plus 255. So if they start out, it's 0 days, right? They're starting out with 255 cars. So after 1 day, they will have sold 30 cars. So 255 minus 30 gets us down to 225. And then each day, as we increase, it's going to be minus 30. So 195, right? So this should be 195 minus 30. 225 is negative 30, right? And this is a rate of 1. So that matches. So our table would end up looking like this. And we already wrote our equation. All right, guys, you should be masters now.